Hi guys! So today we're going to be covering chapter 12, which is going to be the reaction rates and chemical equilibrium. So today we'll begin talking about the reaction rate, which is kind of like how quickly do these reactions that we've been talking about take place. And then we're going to be talking about the reaction equilibrium, right, where you're going to have a certain amount of balance in the equation for or things will begin to shift based off of like the concentrations, and we'll learn more about that. So today we'll just be talking kind of about the reaction rates and the collision theory and a little bit of the conditions. Okay, all right, let's get into it. So reaction rate is a measure of how fast a reaction occurs. So how quickly does this reaction take place? So for instance, if we any of our compounds, right, how we're mixing compounds, we have one compound, let's say like NaCl, and you combine that compound with NaOH. I don't know, KOH, right? So that compound can together, there's a rate at which these compounds come together to create these products, right? So there's some sort of time frame, like there's a measure of how fast that reaction occurs. Does it occur fast? Do these compounds combine quickly and they just combine and move on, or do they slowly combine? What is the rate at which that happens? Okay, and so there's certain conditions that will be set on how quickly this reaction takes place. So the things that are going to affect how quickly this reaction takes place is going to be the temperature, the rate of concentration, reactant concentration, surface area, and the presence of a catalyst. So remember that these are the four conditions that affect the rate of reaction. Okay, so temperature, right, depending on how hot or cold it is, that can affect how fast the reaction goes. How much, right, reactant concentration. So if there's how much of how many moles are in the reactant, it can affect how quickly the reaction is going to take place. The surface area, right? So if there's more area that's being exposed that's able to make a reaction, that could possibly move the reaction faster. And the catalyst is something that we'll discuss as we go forward. All right, so conditions that affect reaction rate. So, right, we talked about temperature, reactant concentration. We also talked about surface area as well as the presence of a catalyst, right? So for temperature, the higher the temperature generally causes reactions to move faster, which makes sense, right? So if you're going to increase the speed or you're kind of breaking up, you're adding heat, what is that doing? That's going to possibly break those bonds, right? Which is going to make it a lot easier for those compounds those new products to be formed. So if you're adding heat, that can break those bonds, and then that will create a quick reaction between the new products, right? Okay, so hopefully that makes sense, right? Increased temperature is going to increase the reaction rate, right? Because you're able to increase the amount of bonds, how quickly those bonds are broken, which means you're going to be able to quickly form a reaction and create the products, okay? So that is the temperature. So the higher temperature, generally higher reaction rate, okay? So I'm going to actually write these out so that you guys can remember this, okay? Temperature. So high, high, temp equals increase reaction. Right. Okay, so for temperature, just remember, there we go. So just remember that as you're increasing the temperature, you're going to increase the rate of reaction. So now let's look at the reactant concentration. So if you're increasing the concentration of a reactant, generally that's going to increase the rate of the reaction, right? So if you're increasing the concentration, then the likelihood of them like combining and creating a reaction from those reactants is going to be higher, right? So if you have more, then you're going to basically have a higher possibility.